Right now what I'm doing is actually it's a 160 volt capacitor test on the new design of this pulse motor. Ended up making some new magnets. Actually made them really small, and they're neodymiums. Put them in a nice little bracket, fits in real nice, and pretty much that's what it is. But I want to show you the back EMF, how I'm actually collecting it. These are just very good boxes. They're very high switching ultra fast diode boxes. As you can see, we have our positive going in. That then gets hooked to the coil, and right now I got all 4 coils in series. We have a 7.3 ohms on our total resistance on the coils, and this one right here also goes to this side, which is also a negative. So it goes through the negative diode arrangement, goes through the coil, and then when it kicks back, it comes back out to the positive. So I'm going from negative to positive, which is basically I'm collecting the return that's then going directly into the simple capacitor bank. And that's pretty much it. Now this is a lot of power right here. About 250 joules of energy in this capacitor bank. And right now I've been just testing the pulse drive on this. What I want to do is just show you what the back EMF is. First I'll disconnect it from the return so you can see the difference in the back EMF. So we are at about 160 volts. So here I go. Okay, 1, 2, 3. I'll do about 5 of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you can see that, right? 5. 1, 2, 3, 4, 5. And you can see, of course, I ain't got nothing in return. Now what I'm going to do is hook up the back EMF collector. And the sparks I'm not going to stop because, you know, you're still putting a load in it once it kicks back. But what this does, it pulls that back into the capacitor bank, and we're pretty much reading nothing. So I'll do the same thing again. Here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now I'm not switching it fast enough like it could, and now my capacitor already built up for over 21 volts in a 5,000 microfarad capacitor. Now the key is, of course, is frequency. The higher the frequency, the quicker it's going to charge, and that's when you get the power. In fact, if I keep going, it'll actually go higher than the original voltage. You gotta watch I don't overload. We're getting there. I gotta watch my eyes. You can see the arc on that. Wow, we're getting there. It's really fast. You got to get that going. As you can see, you can actually weld with that capacitor, but it doesn't look like we're going to get there. But it takes a very high frequency to get that kind of a load. And like I said, this is pretty much what this is doing. I think we're pulling a pretty good load on this. Let me short this out and see how much of a load we're actually going to be pulling. It's pretty hard to try to do this all in one shot. Okay, that gives me a pretty good indication of, okay, I want to discharge the cap. That's my peak. And that's my charging. It charges up really quick. Let's try that again. Should be about, see what we got here in watts. Oh wow, we're pulling almost 1,000 watts in my charging circuit. Now my charging circuit, believe it or not, I have a nitron wire here, which basically is a resistor, and heats up pretty good, but I charge this up really quick. In fact, if I wanted to, I gotta get new different kind of circuits for this, but this thing will actually kick over real quick under one spike. I'll show you real quick, and here we go. I mean, it would be no problem at all if I can time it. The thing will start right over, but the back EMF is what I'm really wanting to collect. And now, right now, this is just a test. I'm not going to use the 120 volt. In fact, I'm going to get a pump circuit that actually will pump this up. So every time it comes around every 90 degrees, I'm actually going to release that energy that's already pre-stored. So I'm actually going to just use one 12-volt battery, and once this is running, the stepper motor, which is a very low RPM motor, will automatically go back into the battery as a charging system. And the back EMF, I will slowly charge back into the battery also. So you got three systems working, and this is actually going to have to run a microprocessor, so there's a lot of advanced electronics on this, because this is some serious power. This ain't, I'm sorry, this ain't a Bandini motor, which Bandini basically copied off of EV Gray and Pulse Adams motor, you might say, because they were way before their time. But everyone copies someone, that's okay. But you got to understand what EV Gray did, and this is basically what I'm working on, a concept of that. It seemed like he actually knew what was going on when it came to the back EMF. So pretty much that's where I'm at, and I got some more testing to do before I start hooking up the electronics. Right now I'm just rewiring everything. It's still the same unit, it's just I redid the whole arrangement inside my rotor, and I have a very unique way how I did that. Maybe I'll break it down sometime and show you how it's done, but I actually have my magnets on an angle like the EV Gray theory, so hopefully everything will work out soon and I'll be able to do another test run. Talk to you later.